comes here as a chapter. Then coming to the storage classes, so in which all ways we can store a data. Okay, so it's called as the storage classes. So that also in detail we have to see. There are also a lot of keywords comes. Okay, we have to see that all the things with many examples, the template examples are there. Then coming to the pointers part 2, that is, I can say this is the most important and the very difficult chapter of this entire module, pointers part 2. Pointers part 2, then coming the function part 2. So in pointers part 2, like here we will be learning only one level, single level pointer. Then here in the advanced, so this is the advanced. So all this from the storage class, there starts the advanced topics. So in here we will be even learning like 2D arrays. Okay, 1D arrays we will learn here in single level. Okay, functions part 1 and 2D arrays, how to work with it. Okay, or multi-level pointers, everything we will learn in pointers part 2. Like that, when coming to the functions part 2, we will be learning command line argument, environment variables, then function pointers. Okay, then some predefined functions and all. Okay, with respect to the functions only, everything we will learn as the second part of functions, advanced topics. Then comes the pre-processing. So in fact, we are doing the programming, compiling it every time. So in fact, we are not knowing what all things are happening in the background. Okay, so in detail, we are going to see the entire compiling process. Okay, pre-processing. That's one chapter. Then user-defined data types, another very important chapter. So from here, everything is very important only. So user-defined data type. So there we are going to create our own data types, and then how to use it, when to use it, which are the types. Okay, all those things. Then file input output. That is a very small chapter. Writing to the file, reading from the file. How can we even do that? Then miscellaneous. That's a very simple, very small topic. Okay, so overall, this is the view. Okay, so half of the module only for the basics only. Then only we will move on to the advanced one. Okay, did you get an idea? So expectation out of this module, it's like by the end of this entire module, there shouldn't be any, like, you should be very sure, like where to use the concept, keyword, like don't just concentrate only on the theory. Programming is always like you have to practice it. There is no other shortcut. If you practice only, you will be clear with the programming. By seeing the template codes or while when I do in the class, okay, by seeing it, you might be thinking, yeah, it's very easy. I'll get it. But I have seen many in interviews like they will be knowing the concept, but they don't know how to do the programming. So to know the programming, you have to do the program. Okay. To do the program, very first thing is there should be logic building. And building the logic is very important. That comes only by practicing. Okay, so if you want to write a program, very simple program, maybe, for example, if you want to find the perimeter of something. Okay, so if you want to find the perimeter, how will you find it? For that, you should know what is perimeter, isn't it? So like that, or if you want to, for example, another example, if you want to write a program to find whether the sides are, if two sides are given, whether the sides are of a square or not. Okay, so to implement, it's a very simple program. To know that or to implement that, first you should know how to do it. There comes the logic building. So this logic building will come by practicing only. Okay, so that's why we have kept that first one as problem solving. How in a step-by-step manner we can reach to the solution. So directly going and jumping to the very or starting with the programming and trying it there itself, that is not a good idea. Okay, always we have to solve from the very beginning. So we will see that one by one. So the problem solving, what is problem solving in the sense? The analyzing the problem. Okay, in which all ways we can solve the problem. Okay, so analyzing problem, that is communicated, like maybe someone else. So if I'm telling you, okay, for example, if I'm telling you to find whether the entered numbers are sides of a square, that's the problem given to you. Okay, so the very first thing is like you should understand that in the way I told. Okay, what I meant and what you have understood should be the same. Then only there will be the solution as I expect, isn't it? So that's the very first thing. So in which all ways we can solve the problem, the very first thing is analyzing the problem. So analyzing the problem in the sense you can write down the problem. Okay, write down the problem is the very first thing that you can do. Okay, write the problem that you have understood. Okay, then what it is, you have to write all the possible solutions for that. Okay, write all the possible solutions. So we have to find all the possible solutions, and then we have to find the best one. Okay, so choosing the best one, or we have to find the best solution, or not really the best one. Always it should be something creative. So every time going with the traditional way of solving, okay, that is not preferred. You can solve a problem in n number of ways. Okay, if you have a problem, you can solve in different ways. So which one you choose, that depends on your requirement, and that should be the best one, best solution, maybe out of box thinking. Okay, so these are the things required for solving any problem. Okay, so we have to always think in a creative manner to get the best solution. So these are the things that you have to do whenever there is a problem. So to analyze the problem, these are the three steps to take, okay, to analyze any problem. So this is what we are going to see in detail. So again, for the problem solving, we have different methods. Okay, first one is SDLC. So we have to see the different methods now in detail. So what is SDLC? We have to see. Then comes the Polias rule. Then comes the algorithm design methods. Okay, three methods are there. So we have to see one by one. So SDLC, do you have any idea what is SDLC? Have you ever heard of SDLC? Yeah, if you have heard, can you please tell what is SDLC? Maybe somebody who is working in some organization might have known software development lifecycle. Okay, software development lifecycle. Okay, so in fact, that is for the programmers, that is software development lifecycle, correct? So SDLC is a common one. Okay, so SDLC means that is system development lifecycle. Okay, the systems, okay, systems development life cycle. So it's not only meant for software, it can be the hardware, it can be any service product. Okay, so when it comes to the programmer, okay, when as a programmer, what we are going to create is nothing but only software product. Okay, so for us, it's nothing but SDLC is software development life cycle. Okay, so this is also correct when it comes to the programmers. So it's used in most of the companies. Okay, so usual practice in companies. So if the requirement is high, okay, like an application development, then the step-by-step procedure will be there to complete. Okay, so there will be a step-by-step procedure to do it. So it's like if there is a bulk requirement, nobody will directly jump onto the solution. Okay, so how that can be solved in a very good manner, that will be analyzed first. They will be spending some time on it. Okay, then only they will go to the final implementation. Implementation thing is the very last one. Okay, so directly jumping to the solution is like it may even end up in very big losses. Okay, that's why usually in industries that's not done. Directly jumping to the solution is never done. They will be following one or the other method of solving the program. Software, yeah, I have already written here. Software development lifecycle. Correct. Okay, so we will just have a look into what all things are there in SDLC. So never jump into the implementation. So I told like it may even um, end up in very big losses. Why? Because there are different reasons. There can be different reasons. So might be the client is giving you a requirement. It may not be the same that you have understood. Okay, so they are telling to develop one application or a product, but you might have understood it in a different way as a different requirement. Okay, so there won't be any like it. There will be a mismatch in the final product created and the requirement. So that is one reason why nobody will never jump to the implementation, and there will be like some mismatch again in the requirements. Okay, so something which is required will be missing at the end. Okay, so apart from the like there will be some mismatch in the requirements also, so somehow loose ends can be there. So that is one another reason for not jumping into the implementation. So what it is, why it is used, or how it is used, we will see. Okay, SDLC, these four steps completely, it's called the SDLC or System Development Lifecycle. Okay, so there the very first step is nothing but the requirement. Okay, here we will see or we will understand what exactly is the input. Okay, so here as a programmer, okay, so you will understand what exactly is the requirement and what is the expected output. Okay, and within what time it should respond, and within what time it should be completed. Okay, all these things. Then using which technology or terminology we have to implement it. So I told there will be n number of solutions for a problem. So it can be solved in different methods. The same thing can be implemented using different technologies. So which one should be chosen and when to complete it? Okay, when that is required. Okay, and or when is the launch time? Okay, that should be known, and there shouldn't be any delay. So usually the products in industry they will be launching with a competition, isn't it? So there shouldn't be any delay. It should be given or developed within the time given. Then what is the input? What is the expected output? Everything should be known at this stage itself. Okay. So, which means, for example, if that is a home designing, so I told it's not only for the software. Okay, in every industry, in every services, this is important, STLC. So, if that is a home designing, so then what it is, when it comes to the requirements, it's like the entire plan of the home should be ready. Okay, like the size of the plot, how many rooms are there, how many floors are there. Okay, which all rooms at which all like at what position and what is the width, length, everything should be known, and even the details in it, isn't it? Even each and every details in it should be known. What is the place for the bed? What's the place for the table, chair, and everything, cupboards, okay, wardrobes, everything should be ready in the plan, isn't it? So the requirement should be very clear. Each and every detailing also should be very clear. Then coming to the detailing again, what type of raw materials should be used? Okay, what type of or which companies iron bars should be used? What type, which companies cement should be used? Okay, so that comes to the very detailing. Okay, so that is also requirement. Okay, so that is what the requirement, understanding the requirement is. Each and every detail of that particular product should be very clearly understood. Then, after understanding what is required, you have to document it. You have to make a document of the things, what you have understood. Okay, so these are the requirement, this is what you have understood. Then you have to cross check with the client whether this is the exact thing that they required or not, or whether this is the technology or terminology that should be used or not, and whether the entire product input and output is like this or not. Okay, like that, everything, each and every detail should be understood at this very first stage itself. Okay, so after cross-checking and getting it verified from the client, so even you should know the boundary conditions. Boundary conditions in the sense how far it should go. Okay, for example, in the case of, for example, if I say that's the web page development. Okay, so like you can keep some boundary, like just assume that's a web page where multiple people are logging in. Okay, so like you can keep a limit or the boundary there is if 1,000 people are also login at the same time, it's not never going to hang. So we can see some pages, some shopping sites and all, they will get hang when a lot of people or when that's a busy hours, isn't it? So like when a lot of people are logging in at the same time, okay, the server will be down. Okay, so like that is the limit. When the limit is over, that's happening. Okay, so like that, the boundary conditions can be kept. So 1,000 people or 1 lakh people can log in at the same time. Okay, even though the web page is going to work fine, that is the boundary condition. Okay, so like that for every product with respect to, so when it comes to the phones, mobile phones, then it's um, like what is the maximum memory that to be used, or what's the size of the phone, okay, the size or the thickness, okay, or everything has a limit there, isn't it? Or what it is, that everything is competitive. In fact, when it comes to the phones and all, each and every feature, each and every factor is competing, like they will be competing with one another company who will be manufacturing similar product. So that also, these boundary conditions also matters, isn't it? So the requirements are very important. Saddam Hussein, I didn't get that your input. Did you meant to say something? The traffic? Okay, can make it clear. So I hope this much is clear for you. The requirement. Is there any doubt? Okay, Saddam. Well, thank you. So is this much clear for you? The very first requirement. Okay, so that's a very important and very first step. If something goes wrong here, then your entire project will be going to be wasted. So next one, the design is like visualization of all the things that you have understood. Okay, visualization, like what exactly is have you understood? What exactly have you understood? All the requirements. You are going to visualize it using one or the other thing. So maybe that's a flow chart. Maybe that's for example, I told the example of home design. So it might be a tool, a 3D tool to visualize it. Okay, so something like that, maybe software or some hardware. It can be something to visualize the plan. Okay, so visualizing the things that you have understood. Okay, so it can be an algorithm as well. So the product, there we have to consider the product with all the requirements. It's the derivation of the solution by the architects, if I say. Okay, or the programmer. So derivation of the solution. So we are going to the next step. So these are the requirements. This is how the product should look like. Okay, so there we are even going with the, if that's a phone, we are even going with the color and the size and the dimension, everything will be clear there. Okay, so even the dimension that comes as the requirement, even the colors, which are the colors in which it's going to be launched, that's also the requirement. So we are going to visualize it with the product with these colors or these dimensions or these uh, size of or this is the limit for the memory. Okay, so like that we are going to visualize it with all the things. Okay, so entire things, even the maybe the what is the OS there? Is it the Android and which version of the Android, or is it the iOS? Okay, so that depends on the company and its then what exactly their requirements. Okay, so it's a derivation of the solution by the programmer or the architecture or whoever has designed it. Okay, then the third one is like, so here what we have to make sure, like everything should go in a step-by-step manner. Okay, so you can use a flowchart if required. So what is the flowchart? If you don't know, we will see it. So we can even use paper and pen method. Okay, so we can write down the steps one by one. What comes first? That should be done first. Okay, then so it's nothing but a proper design plan. Where we have to start, where should we end the project? Okay. Now the next one, if the design is proper, then we knows what comes first, how to do it. So that is the implementation part. So implementation in the sense is not the final program or final solution for the problem. So it's like the converting, like whatever we have done as the design, we are just converting that as the coding. Okay, so it might be the algorithm or the flow chart or the program without using the syntax. Okay, so the program without using syntax and semantics, that's in fact known as the pseudocode. Okay, so like that, it can be a skeleton code. Okay, the skeleton code, which means the set of like these are the inputs required, these are the types of output required, but we are not checking for each and everything. Okay, so modular structure in the sense we should have a program which is with the minimum number of lines and with maximum efficiency. Okay, so we have to keep it as simple and as small as possible, and that we are not compromising on the efficiency. Efficiency should be the max as possible, but the code should be kept as minimal as possible. Then implement the code based on the derived algorithm or the flowchart or whatever design plan we have done. Okay, then always while doing the programming, you should go with the indentation. Indentation in the sense that's a proper spacing. Commenting is important. Why? Because maybe you're writing the program today, someone else is going to work with the program tomorrow. So even they should understand what it is. Okay, for example, if I say, I told at this stage it will be the skeleton code. Okay, the skeleton code in the sense it will be just having the input and output types required. The requirements only will be there, but the one who is testing will be someone else. That is a test engineer. Usually, he will be testing the program. So if he has to test the program, then he should understand what's written there, isn't it? So that is why the commenting is very important. Whenever you write the program, you have to write the comment so that someone else who reads it should understand it also. Okay. Then good variable and function names. Okay, so variable names, function names, everything should be appropriate so that anyone who is reading should easily understand the program. Okay, so it will make the program more communicatable, like it will be more understandable. Communication will be easy. Okay, then neat file. Okay, so like neat spacing and neat file. Okay, file names and the function header. What is function or the header files and all that we will see later. So as of now, understand overall it should be very neat, very modular. Okay, that's how you have to write the program. Then the testing is nothing but we are going to do all the input and output, all the positive, negative cases, everything will be tested for all the possibilities. Okay, checking for the bugs or the loopholes. Is there any bugs? So you can even for every software product you might have seen, like there will be a stable version and there will be a latest version. Stable version in the sense which is out of the bugs or loopholes. Okay, latest version in the sense it's under testing. Okay, so we can use that software and we can say if there is some loophole or the drawback or some bugs are there. Okay, so there will be manual testing, there will be automated testing also, and there will be a testing period also, like for some days or for months maybe. Okay, so it will be there. So if you have seen, you might have seen it, like in case of software products, always there will be a latest version and a stable version. So that latest version will be under testing. Okay, so that's the thing. So these are the different steps. Requirement, there we are understanding all the requirements, the terminologies, how it should be done, what it should be done, everything, and we are just getting it verified from the client. Okay, then we are visualizing whatever we have understood with the terminologies and whatever need to be used, and then we are going to create the skeletal code, and then we are testing it with all the possibilities, including all the negative and positive. Okay, and then only we can say if the testing is also successfully completed, then only we can say the program or the final product is done. Okay. So is this clear for you? The SDLC completely, is that clear for you? Any doubt here, anyone? Okay. Well, so the SDLC is the first one. Second one is Polias rule. Okay, Polias rule is again very similar to the STLC. So that is again like understanding the problem. That is the first one. So from where this Polias rule comes in the sense, the Polia he was a mathematician named George Polia. Okay, so he wrote a book in 1945, and it was like the ways to solve the mathematical problems. Okay, so there he had this Polias rule. In that book there was the Polias rule. So the Polias rule says how, like it again says, to understand the problem first, then devise a plan, that is the designing, then implementation, carry out the plan, and then look back again in the sense, if something goes wrong, again you have to start from here. Okay, the same thing in SDLC also. If something goes wrong here, then again we have to see from the requirement if everything is correct or not. The same thing is given here. Okay, so understanding the problem, devising the plan, carry out the plan, and then if there is any error, then again go to the first step, correct it. Okay, from there again we have to correct it. So that's the Polias rule. Then comes the algorithm way of solving the problem. Okay. So in this algorithmic way of solving the problem, we are not writing the program. Okay, so without writing the program, how will you find the solution? Okay, it's like if you want to make a curry, okay, make a dish. So how will you like the recipe for the dish? That's like the step-by-step procedure to make it, isn't it? So without making the actual dish, we knows how to make it. Okay, so the same thing here. Without writing the actual program, we are writing how to do it. Okay, so it's the step-by-step approach, and that's like there shouldn't be any, like you can say, a sequence of unambiguous instructions for solving a problem, which means it's a step-by-step approach itself, and there shouldn't be any confusion. Okay, which means if 10 people are reading the same step-by-step procedure that you have written, okay, all the 10 should understand that in the same way. Okay, so that's the thing. So algorithm is needed to generate the correct output in finite time. So finite time, it has so much of importance. So whatever solution that we are finding, that should be like if you, for example, do you know the Rubik's cube? You might be knowing, isn't it? The different colored cube that you can of six. It's like the one color in one side. Okay, that's the Rubik's cube. So this Rubik's cube. So if you check in like in internet, you can see a lot of solutions to solve it, isn't it? A lot of solutions will be there to solve it. But which is the best one? How will you say? Which is the best one is nothing but one which can be solved in the least time, isn't it? The solution with which we can, so it's like one color on one side. Okay, so on the one side, it should be only one color. So how can we get that one color on one side? Okay, one side of the cube. So we can make or in two seconds also, or 2 minutes also, or 1 hour also we can take, isn't it? So it can we can reach to the solution in different duration. So which is the best solution? There is nothing but the one which can solve in the least time. That is the finite time. Okay. So that is like if that's a competition always, one who solves in solves first will be the winner. That's the thing. So the correctness of the output matters. It should be exactly the same. Okay. And it should be like with the finite time. Timing is very much important. So the solution, so if you have n number of solutions, which is the best in the sense, even if that's the programming, the one which can give the output immediately or which gives the output in the least time. Okay. Then better prediction in the sense like you should have a view, like a view should be there, like how far you can go with the input output. Then like there may be some many algorithms to solve the problem. Okay, so if you go beyond some limit, is it going to work fine, or is it going to work undefined, like the undefined in the sense unpredictable? So how far you get a proper solution or a proper output, that you should predict. That is a better prediction. For every input given, the output should be correct or not. Okay, for which all inputs the output is correct. For what range the output is going to be correct. Beyond what range the output cannot be predicted. Okay, that should be known. That is the better prediction. So you should have a view about the input and output. What all types of input can be given? What all types of outputs will be there? What is the range? All these things should be known. Okay, so these are the needs of why the algorithm is needed. These are the advantages of using the algorithm. Algorithm will give a correctness of the output. Okay, what is the output? What is going to be the output? Okay, in how much time will you get the output approximately? And what or how far you can go with the input testing and the output. Okay, how far it's going to be correct. All these things you will get an idea from the algorithm. Okay, so algorithm again it can be written as a natural language. We can write the step-by-step things as one by one in a natural language. So the natural language can be your native language, mother tongue, or it can be the English, the universal language. So anything. It can be a language with which you are comfortable in. Okay. And you have to write the step-by-step procedure using that language. So there doesn't comes any coding or even the syntax. Nothing is coming to the picture. You are just writing each and everything as words. Okay, that's all. Then the second one is pseudocode. The pseudocode can be used who has at least some knowledge in programming. Okay, which means he knows he has some idea on the program, so he knows a little bit of syntax and all. Okay, so in that case he can just he doesn't have to do the entire coding with the syntax, but the overall things. Okay, so without using the syntax, writing the overall things, or it looks like a code. Okay, but we cannot execute it. Such a code is called as the pseudocode. So it looks similar to the actual code, but the syntax is not used there. So in that case, what it is, it's very easy to convert to the actual code. The next level implementation will be very easy. Okay, from the pseudocode, right, implementing the actual code is very easy. Conversion is very easy. Then comes to this, that's the flowchart. Okay, flowchart in the sense we'll be using a set of shapes to show that that is the input, that is the output, this is the operation, and this is the set of what exactly the or the operations or the loops that we are going to use. So what is loop parallel? We'll see. So something going to repeat, that is in fact the loop. So all these things we can just draw and show. Okay, so the design is in fact uh, drawn here. Okay, so we are going to draw something and the step-by-step procedure, that steps we are going to draw one after the other. Okay, then we are connecting it using some arrows from where to where it goes to the next step. Okay, so that's the flow chart. So these are the three things that we are going to use. We are in fact going to go with the algorithm method of problem solving, not the SDLC, not the Polias rule. We are going to use the algorithm method of problem solving. So in the initial days, I'll go with the natural and all the three. Then we will switch on to the pseudocode and the flowchart. Okay, then we will practice with so many examples. Okay, is this much clear for you? Hmm? So we will have a look into one problem here. In this problem, we are going to see the different types of algorithm. So I told whenever there is a problem, there can be n number of solutions. One problem can be solved in different ways. Okay, so one daily life example we have taken. So it's like the you're going to office from your home. Okay, so which are the possibilities? Every possibility is one algorithm. Okay, so the different possible approaches to reach the room or reach the office. Okay, so you can go by walk. Okay, you can go by walk. You can take a bus. You can take a car. You can go by carpool. Okay, pooling. So, what are the advantages and disadvantages of each algorithm here? So, each algorithm differs from others, isn't it? So, we are going to see what are the advantages and disadvantages. So, first one, take the walk. So, can you say what are the advantages and disadvantages of having the walk? Time management is a good thing or bad thing? Yeah. So, that's a disadvantage. Okay, the time management. Almost. Zero cost, that's an advantage. You don't have to spend the money. Yeah, cost effective. Good for health, correct. Good for health. Eco-friendly, correct. So you can save the money, but you have to spend the energy. Okay, so it's like this, for example, you should have a good time prediction, isn't it? Like when you should start, when will you reach the office, that should be well understood. So it's like the steps. So this is the algorithm now. Okay, so from where you should start. So if you want to reach by 9:30, for example, you have to start at 8 a.m. Okay, very early. Start at 8 a.m. That's the first step. Then walk through the street X for 500 meters. So starting from here, your home, walking from here to the street X for 500 meters. Done. After that, take a left on the main road. So you are turning here, left on the main road, and walk for 2 kilometers. Then take a left again. Okay, then walk for 200 meters to reach. Okay. Yeah, time takes more. Person will get yes, correct. So the thing is like you are walking how many kilometers? So 2 plus 5, 2.7 kilometers you have to walk. Okay, so that in the early morning 8 a.m. time. So that will be like very tiring, isn't it? So 2.7 kilometers that in the early morning, like not early morning, 8 a.m. So that time you will be very tired. When you reach the office, you will be tired. Okay. And the other thing is like you will be sweating, so the freshness is gone, isn't it? So you're going office, so that's not a good thing. So the freshness will be gone, and then the advantages are nothing but you don't have to wait for anyone, you don't have to wait for anything. You can just you know that when you start at 8 a.m. you are going to reach on the office in right time, isn't it? So you are not wasting any time in between. In between, you are not wasting the time, so that is the advantage. Okay, so good time prediction, then you like good exercise, you are saving some money. Okay, and the disadvantages is we have to start very early, we'll be tired, freshness will be gone, and depends on where you stay. So if you are staying very closer, good. If you are staying very far, then it's a bad idea to walk in the morning. Self-dependent, correct. So if you are, so in this case, it's like only 2.7 kilometers. What if you stay some 5 kilometers away? What do you mean by pro in the sense that's the advantage, pros, cons in the sense that's the disadvantage. Okay. So I hope everyone can understand this. Pros in the sense that's the advantage, cons in the sense disadvantage. Pros and cons. That's like advantages, disadvantages. Okay, so this is the next algorithm that we have to analyze. So if that's the bus, then we can start a little more late, isn't it? Comparatively, we can start a little late, like we have to start by 8:30 a.m. now. Then what it is, again walking for, or you have to reach the bus stop. Okay, so bus stop you have to reach. So you have to walk 500 meters. So in this, okay, the same picture. You have to walk till here, then you have to reach again. Okay, it will be not immediately here, somewhere here maybe. So you have to walk till the bus stop. So after walking, after reaching there, you have to take left on main road, walk again 500 meters to reach the bus stop. Okay, so totally 600 meters you are walking there itself. Then you have to wait for the bus. Wait, bus has to reach, it has to stop, then again like it, then you have to catch the bus, you have to get down and in your next stop, and then again walking for 100 meters. Okay, so that is the bus stop. From the bus stop again you have to walk on the main road for 100 meters. So totally now 500 plus 100 plus 100, you have walked already 700 meters. Okay, then again you are taking left and walking 200 meters. In 900 meters you have done. So what it is, again you will be a little tired for walking 900 meters. Then you have to wait for the bus. Okay. So the bus may reach, may not reach. Even what if the bus breaks down? Okay. Or what if it's a very rush? Okay. The 8:30 a.m. and all, it's the rush hours. So yeah, like you have to even go in middle of the rush. Okay, that's not a good idea. So you will be again, in this case also, you will lose the freshness. Again, yeah, traffic. So the traffic jam can happen in between. So, so many things. So the advantages or the pros, you might save some time. Time is a little bit saved, half an hour is saved, but less tiredness comparatively. Yeah, than walking 2.7 kilometers, you are walking only 900 meters. Comparatively less tired. Then cons or the disadvantages, you have to walk to the bus stop. Then again, after getting down also, you have to walk from the bus stop. Okay. Have to wait for the right bus. What if no? That's not reaching on time. So we can't predict over the time. It may come, may not come. Okay, we'll be late sometimes. So we have to bear with all this. Then might not be comfortable on rush hours for sure. We won't be comfortable on the rush hours. So they are the disadvantages. So that is the advantages and disadvantages of this particular algorithm. Okay. Then the next algorithm is taking a car. So taking your own car, that's the most comfortable way, isn't it? So you can start at 9 a.m. A little more late. Okay. If you want to reach the office by 9:30, 9 a.m. is fine. Then you have to drive. You have to drive from your home till the office. So 500 meters onto the main road, then 2 kilometers in the main road, then from there again 200 meters you have to drive. The entire way you are driving. Very comfortable within your car. You will be alone. There is no rush. But again, what are the disadvantages? You have to spend more money, isn't it? Comparatively, this is the expensive method. Yeah, cost. Then you have to bear with the traffic. Okay, what if the traffic jam happens? Okay, so you won't be tired, less tiresome. Yeah, have to spend money. Yeah, convenience. Yeah, the convenience or the comfortability will be very high. Proper control of time and most comfortable. That's the thing. Okay, proper control of time will be there and most comfortable. So could have issues on traffic congestions, will be costly, expensive method. So yeah, car maintenance, everything, that is why will be costly or expensive. Okay, the petrol, everything matters. So this is the third method, third algorithm. And again, it has the advantages and disadvantages. Then coming to the fourth algorithm, again we can start it early. We have to start early. So instead of 8 a.m. in case of by walk, 8:30 a.m. in case of by bus. In this case, that's the pool. Okay, the car pool or some pool. So that is like you can start by okay, pooling in the sense what? I hope everyone knows. That's a sharing, like it's like sharing the car. Okay, sharing car or maybe pool bike is also there. The car is the most common one. So like some people are sharing and going together. Okay. So in that case, you can start by 8:45 a.m. Then walk through the street. So it won't be reaching next on your doorstep. So you have to walk to the main road. So a little bit of walking, then you have to wait for the others to reach. Okay. Yeah. You have to wait for the others to reach. You have to wait for the vehicle to reach. So a little bit of time for waiting. Then driving for 2 kilometers, again driving. So till the office, from the main road till the office, it will be driving. Then again, whether you are comfortable with the others who are in the car. Okay, is it comfortable going with them? That matters. Comfortability, that matters. Then again, that is the car, so traffic congestions can occur. But comparatively, than taking your own car and going alone, this is comparatively less expensive, isn't it? So yeah, time and cost saving. So you can save some time. You can. This is less costly comparatively than taking your own car. Okay, but costlier than the other two methods, taking the bus and taking going by walk. Then disadvantages: have to wait for the others to reach. Okay, again the traffic congestion. Okay, so we have discussed four different algorithms. Everywhere you can see there is advantage and disadvantage. In all the methods there is advantage and disadvantage. So which one will you choose? Hmm? Of this, which one will you choose? Which can you say as the best algorithm here? Everything has at least two disadvantages and advantages. So we can't easily say which is the best algorithm. So the whichever problem it is, yeah, whichever problem it is, the algorithm, which is the best algorithm, that depends on the requirements. Completely depends on the requirements. If you are staying very close to your office, then walking is the best solution, isn't it? So if you are staying very far from the office, then walking is not at all a good solution. Then if the buses are frequent in your route, then taking the bus is the good solution. And at 8:30 a.m., you should predict there will be a rush. Okay, that's a rush hour. So you have to compromise with that. If you're okay with that, then fine. The bus is the best solution. If you're comfortable with your car, you don't have any problem in spending the money, then the car is the best solution. Again, you have to bear with the traffic. Again, what it is, pool. There also you can share. If you are fine with the sharing, then the pooling is the best solution. So it depends on what is the requirement. Okay. So depending on the requirement only, we will finalize the solution. There can be n number of solution. From that, which is the best one, that completely depends on the requirement. Okay, whichever problem it is, whatever solution it is, there will be some advantages and disadvantages for each and every solution. Okay, so this is one thing that you should understand now itself, and then you have to keep in mind when you are working with the actual problems. Okay. So that's what in fact given here also. Every approach has some pros and cons. Which one to be chosen depends on the requirement. So the actual algorithms, how to start with it, how to write it. Okay, we have to start with it. So in the sense, let's consider a problem of adding two numbers. Okay, adding two numbers is our problem. So we have seen a real life example. Then we are coming to the actual problems that we are going to handle. So adding two numbers is our problem now. So we can write it in different ways. Different ways in the sense you can write it in natural language. You can write it in the what exactly the pseudocode. Then you can draw the flowchart as well. Okay. So if we see, we will just solve this one. So our problem at two numbers. Okay. So first we will go with the natural language. So in natural language, how can we write it? So there will be a start and end for every problem. So every solution. So it will be the start. That's the start of the algorithm that you are going to write. Okay, algorithm. So the algorithm writing can be the natural language, pseudocode, and the flowchart. So start of the algorithm, that's the first step. Then just so that's the first step. Okay, start of the solution. Then the second one is like we have to add two numbers. So what are required here? What are the requirements here? Hmm? We need the two numbers. So we should read the numbers. Reading in the sense taking the input. Okay, taking the input, we can ask the user to enter two numbers. Okay, so if that's in the program, we have to read from the user. So reading some using some method. Now we don't know which is the exact method. Using some method, we are going to read two numbers as n1 and n2. Okay, I'm even naming the variables where I can store these numbers. Okay, then what it is? Third step, what should I do? Adding. Okay, so I should add the numbers. Add command or something. Let it be later. So reading the numbers from the user. So adding add n1 and n2. Okay, then I should store it in some variable. Okay, I will just name it as sum. Okay, so I'm writing everything like when it comes as the natural language, I'm writing everything as sentences only. Then this is the third thing what I have to do. Then fourth thing, what should I do? After storing it in the variable sum, I should verify it whether it's a correct sum or not. So I should go with the display of output. Okay, display sum or that's the output. Okay, display sum or display the output. Then what it is? So that's the actual problem and that one solution. We had adding the two numbers and displaying it, it's done. So that's the end. Okay, so I'll just give stop or end. Okay, we have to convey that is the end of the solution. So this is how we can write the algorithm in natural language. Then when it comes to the what exactly flowchart, we will see. Before that we will go with the pseudocode. So with the pseudocode, what it is, it will be the same thing. Pseudocode, the same thing will start with, or it's like the instruction. Okay, so we have to, you can even go with the start stop or start end, or we can even give begin. Okay, so for a difference we are giving the begin and end. Okay, so something which looks like the instruction, begin the process. Okay, so then it's like reading N1 N2. Okay, so reading N1 and N2, instead of that I'll just give the read N1 N2. So it's the like separated with comma, like somewhat like, so almost like this is the way how we are actually going to read it. So separating the multiple variables with the comma. So we are writing it in the similar way. Okay, but not with the read. We don't have anything like read command or a read function here in our C program. Okay, so read. Okay, so which function to use and all that we will see later. So it's like we can use something here to read N1 N2. Okay, now the thing is like, what should we do? We have to write this almost into as an expression. So we can write sum equals N1 plus N2. We are now writing the same thing as an expression, adding N1 N2, storing it in sum. Okay, correct, Sandeep. Then the fourth thing is what? Displaying the output. So in like usually when it's the system, we will say it as printing, isn't it? So printing the output. Print sum. Okay, then that is the end of the pseudocode. So it's the same end. And I'm not telling these things are mandatory, like you must use begin and end, you must use start and stop. Even in pseudocode, you can use start and stop. Okay, so it's not like something mandatory. It should be understood as it. That's all. Okay, and when it comes to the natural language, it should be understandable. Whoever knows this language should understand this. That's how you should write it. Everything in sentences. When it comes to the pseudocode, wherever expressions are possible, in that way we have to write it. Okay. Now coming to the flowchart. To understand the flowchart, you should first know which are the basic shapes that we are going to use. Okay, so I'll tell you one after the other which are they. Then we have symbol circle is there. Okay. So what is meant by the elliptical shape? It's okay. So many are there, some more are there. These are the things that we are going to use. So the elliptical shape, that means the start or stop of the process. For these things in our flowchart, we are going to use the elliptical shape, start or stop. And this can be any operation. Okay, for example, if that is the addition, that's an operation to be done. Then this is for the input output. Input or output. Reading the input or displaying the output. Okay, all those things comes in the parallelogram. Then the diamond shape, it's for decision making. Decision making. So there can be like based on the decision making, there can be an yes or no. Okay, depending on that, there will be two solutions. Then this is the connector. So if you want to connect it over to another page, okay, so that is where you usually use the connector, or continuation is somewhere else in that case. And this is to connect the different blocks, that is the arrow. Okay, so these are the things for the, or I can say that is the flow. Okay, flow shows the flow, the arrow shows the flow. So these are the different things that we are going to use. Then we'll just quickly see the flowchart for this one. Okay, so according to the pseudocode, we'll just do it, or we can use the, I told, we can even use the keyword, sorry, we can use the word start and stop. Then we have to read N1, N2. So input and output is in parallelogram. Then we have to find the sum and store in it. Then we have to display it. Then we have to end the process. So end the process again using elliptical shape. So every time, remember, you have to connect this flowchart using the arrow. That's the right way. Start, then the read N1, N2. Then we have to do the operation sum equals N1, N2. Sorry, N1 plus N2. Okay, then we have to print it. Print sum. Then that is the stop. Okay, so this is the flowchart for this particular problem. Okay, so we have done the flowchart for the very first one. So the step-by-step procedure is shown That's a diagram. That is the flowchart. So is this clear for you? The three methods, all the three methods, the natural language, pseudocode, the flowchart. Is that clear for you? So we have to practice with a lot of problems like this in the coming class. So almost the same thing is given here. Okay, writing it in similar way, and the flowchart for the same. Okay, the rest of the things like how to even print the patterns. Pattern printing we will see at the end. So before that we have other problems like this to do. We will do that. Okay. So do you have any doubt till here in today's class overall? Do you have any doubt? Do you have any questions? Okay. Well, if so, we will wind up the session for today. We'll continue tomorrow. Unless I make something. Okay. Get this in practical. Well, we will do a lot of problems like this. Okay, don't worry. We will practice it, then we will go with the. After practicing all this, a lot of things to be learned before going with the actual programming. Okay, all the basics we will clear first, then we will go with the actual program. So whatever we do in class, practice it. Okay, practice it. I'll give tomorrow. I'll give some classworks as well. Then you should get to know like where you are going wrong or what to be done. If you are stuck somewhere, then don't hesitate to ask the doubt. Okay, so well, we'll wind up this resolution. Thank you for attending, guys. You can leave the session for today. Today, I'm not taking the attendance. I'll update it, but from tomorrow, we will take the attendance. Okay, in class or by the end of the class itself, the attendance will be recorded by you. Okay, you have to mark the attendance. So be attentive. So thank you for attending. You can leave the session now.